All right, amateur video, right? All right, so how should I start this out? What? People all over the world don't know anything about how the universe is set up or structured, right? They believe that in order to understand how the universe is set up, they need to have a doctorate in advanced quantum physics or mathematical theory or something like that. But in actuality, the universe is quite simple, and um, even a child can understand it. And in fact, children can understand it even more readily than adults because adults have been conditioned to believe that something like the universe is beyond them and unfathomable when it's relatively simple to understand. I don't know why people make things so complex. I guess they like to live in a world full of mystery that gives them a sense of evolution, right? Where they can not know something and then suddenly know something and then go, wow, we're advanced. Or perhaps they just don't want to believe that they're capable. Anyway, it doesn't really matter. Here on this sheet of paper will be all the answers to everything, or at least a blueprint for all the answers. In fact, once I explain the structure of the universe here, it will actually probably create more questions than answers. And those answers are beyond the scope of this video. So this will just be a blueprint, and but if you don't want to know the answer, then I suggest stop watching the video and just stay um, in the world you're living in. But if you want to know the answers, want to see how far that rabbit hole goes, then just come on and watch the end of the video. Also, I'm not here to blow your mind or freak you out, but that may happen. Even though I'm saying to you that that might happen and letting you prepare yourself psychologically for the possibility that your mind will be blown, your mind will probably still be blown. All right, so here we go. All right, so I did just say that you don't need to know a lot about science and a lot of math and things like that. But I will give science their 2 cents. And what that means is that generally speaking, people don't really know about atoms, subatomic particles, and things like that unless they went to school, so they have an education. So I apologize to those people who don't have that education and don't understand what atoms are. But since from my lifestyle, I know what atoms are, I figure that most people do. And it's not too complex to tell people what atoms are. So I'll start from there because I thought it was a good baseline. Remember, right now, the uh, metaphysicists and so on, they can't really come up with a unified principle between the micro world and the macro world. And so they have like draw strings between the two. They call it string theory. But this is all nonsense. But it's a good effort for people who are capable of only thinking to a certain level. And I understand why they would think science and mathematics can provide the answer when there's so much other ways to judge or to determine the nature of things. I can go into the flaws of mathematics in another video, just like I can go into evolution, I can go into life after death in other videos. In time, this will give you a basic line of the universe as we perceive it as human beings. Alright, so here's a pen, and here's a piece of paper. Sorry. So, as we know, there are all those a little bit smaller than this, but it's not really practical and not really necessary for me to explain the nature of the universe by going smaller than an atom. Okay, so basically, in an atom, scientists have decided that you have a nucleus, right? That's the center of the atom, and then you have electrons. That's the outside of the atom, right? And so these are spinning, oh, maybe in that direction, very fast. And you also have protons around here somewhere. Okay, so that's one atom. Of course, when you look at an atom, the life of an atom is very short. What that means is as soon as you pretty much look at an atom, it's kind of gone. And that is understandable, and the things that are below the atom, they are so short-lived that they're almost only mathematically theoretically to exist. And some scientists even believe that the very fact that you observe some of these things, the observation of it causes it to disappear because it interacts with it somehow, almost like a psychological effect of simply observing it. And so anyway, you have this atom, and we all know that atoms together make up molecules, and molecules are basic blocks of elements, right? And the Earth, everything's made of elements. So let's start with the atom. This could be any atom, doesn't really matter. And then right next to it, you'll have another atom, like this, right? This is, sorry for the crude drawing. Maybe someday when I have a lot of finances, Oprah Winfrey wants to give me a call, I can come up with a better quality video. But right now, you have another atom like that, okay? Like I said, this can be any atom, doesn't really matter what it is. Then next to that, you also have another atom, and you have the electrons around it. And so let me draw this a little quicker. Right, so you have it, and so you have an atom, you have an atom, you have an atom, you have an atom. So, like I said, atoms aren't static, so they're not like these little tiny balls, just staying balls. They kind of come and go really quick, really quick. So, in a way, they exist mostly theoretically, but under an advanced electron microscope, you can see atoms. So, these atoms on a surface of matter, so you have the atom expanding into an atom and then collapsing and then another one expanding. Oh, it's really not that complex. Most people will just agree to this. Okay, so it's sort of like a sine wave. Right? See if I can draw this correctly. Kind of crooked. Right? So atom, 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 atom. So basically, if you look at the surface of any matter, or most matter, under electron microscope, it'll kind of look like a series of atoms and bumps and things like this, but they're all in a nice uniform, like pores on the skin, just a nice uniform pattern, and no atom lasts any length of time. They just kind of flow into each other constantly. So you have an element, right? So that's pretty cool. No big deal. Who cares? So now what you have is these atoms make up an element, which is basically the world we kind of function on a daily basis. So, you know, like iron is an element, copper is an element, things like that. So you put those together, you have things. So then what you have is a big leap from this. What you have is the Earth. Okay, this is Earth. See, Earth. Okay, and the Earth spins around itself. I guess you want to say it that way, right? But then you have the sun as well, the big bright sun, right? And the Earth also spins around the sun, right? So everybody knows this. It's part of our solar system. There's no need for me to draw the other planets. Okay? It is interesting that let's take a look at time. If you think of an instant in time, understand? Take an instant in time, then not a lot changes here, right? But that same instant in time on this atomic level, a lot of changes, right? So from our perspective of time as human being, an instant from this point of view is much longer than an instant from this point of view. So I wanted you to think about that for just a moment, because it's going to be necessary in the next thing I talk about. Now, scientists, they have this understanding that in some circumstances that like some particles act as a particle, and sometimes they act like a wave. Well, if you look at the Earth like this, and you look at the sun, they look like particles. A particle Earth, particle sun. But as you know, the sun isn't just sitting there quietly in one spot. It's actually moving because it's spinning around the galaxy, right? So when that happens, you have the sun moving, right? It was here, and then it goes to there, and it goes to there through time, right? Long time, right? The Earth is spinning around the sun. So in actuality, what happens is this to the Earth. See that? The Earth is moving just like that. Oh, what a coincidence. The sign, it just must have been a coincidence. It can't be similar. But if you add a little bit of time, then what happens is the particle now acts as if it's a wave. So is it a wave sometimes? No. Is it a particle sometimes? No. It's a particle and a wave at exactly the same time. However, our human senses and the way we perceive things may make it look like one or the other, depending on what it is we're looking at. Anyway, that solves a lot of problems that mathematicians can't figure out. It's very simple. Draw it on a piece of paper. All right, so most people are familiar with the solar system. So let's just say this is the solar system. These are the planets. You know, it kind of looks like this, but we just don't need to focus on that because the Earth and the atoms aren't the same thing. The atoms are really tiny. Earth is much bigger from our point of view, anyway. So you have the solar system, but then you have the galaxy, right? So let's just, now scientists say the galaxy is expanding, so let's just say yes, it's expanding, let's not disagree. And so that means you have, in the solar system, you have, it's too much difficult to draw, but basically you have trillions of planets and stars circling around in a spiral-like motion, and the center of the galaxy, similar to what happens with the Earth and the Sun, is that the planets over time actually fall into the sun, okay? They're spiraling into the sun at a very slow pace. Nothing we need to worry about right now. But once they finally swallowed by the sun will absorb those planets, and the dust will go to the peripheral of the solar system. And then that dust will gradually gather over time and form into another ball on another planet on the edge. And the whole thing keeps repeating itself over and over again. So sort of the same thing happens with our galaxy. But right now our galaxy is expanding, so it's not quite happening like that. So now that this is spinning around and around, actually, if I think about it, no, our galaxy could be expanding or contracting, doesn't matter. So we're all spinning around. You got trillions of stars. I mean, you know how far away they are. It's ridiculous. I mean, the nearest star to our star is like, I don't know, 40 trillion light years away. So anyway, this is our galaxies spinning around. So then, this is where you run into the end of the story with most scientists today and most people today. After the galaxy, you have an expanding universe consisting of billions or perhaps trillions of galaxies themselves, right? So let's say these are all the galaxies. These are all trillion of them, right? And you could say this is like the center kind of the universe, so to speak. But like I said, sort of the same thing that happens with the sun happens with here, a little bit different. But that's really not all the end of the story. What happens is you have our galaxy, our universe actually, which consists of trillions of galaxies, right, and expanding. Then you have plenty of space. So this is going way out there, right? So in other words, like when the galaxy, the solar system, it takes 200 million years for the Earth to go around the solar system, to go around the galaxy one time. So from our point of view, 200 million years is quite a while, right? But from the universe's point of view, which is infinite and eternal, 200 million years really isn't any time at all. All right, so you have this universe with all these galaxies. Then right next to it, you also have another universe. And then next to it, another universe. And you have a collapsing universe, and that's just like our galaxy expanding, you have the universe expanding, but then next to it you have a collapsing universe. The next to that one you have an expanding universe. And the next to that one you have a collapsing, then expanding. So it kind of looks like this. If I can draw it, I'm a terrible drawer. Right? Universe, 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 universe. See, as you notice, it follows the same pattern. There's nothing unique or different about any particular level. Okay, so from a universal point of view, from a time point of view, this galaxy, this galaxy, is expanding and collapsing at a high rate of speed, just like the atoms. But from our point of view, this will take trillions and quadrillions of years to actually occur. But from the universal point of view, an infinite amount of time really is just an instant. Okay? And this is happening all the time. So here's the thing. If we have these universes, so you could say it's a multiverse if you like, or at least for the moment you can say it's a multiverse until I tell you what happens next. Hold on, let me fix the computer screen a little bit here so let me see what's going on. Alright, there you go. Hold that over there like that. So, if you're curious, this is where I'm at. So if you're curious about what happens next, this is where you're going to have to come to an understanding that all of reality is simply a perception. There is no separation, and there are certain rules of the universe. Opposites attract, likes repel, the bigger the front, the bigger the back, and everything in its extreme becomes opposite. So in the extreme, which is right here, you have all the universes, and if you notice, okay, and this continues on for pretty much eternally, this, if you look at it from a great distance, it looks exactly like the surface of material of matter. So basically, from the smallest unit, as soon as you get to the largest portion, it immediately becomes the smallest. So as you enter the largest, simultaneously you're entering the smallest. And so this is sort of like as you get to the largest, it's becoming smaller, largest becomes small. There is no, this and this are one and the same. There's no separation between them. There's no division whatsoever. And the endless expansion of the universe and the multiverse is actually the same as endless contraction. Infinitesimal and the other word. So the macro and the micro are the same. So you're wondering, how is this possible? Does our atoms contain universes? No. When you look up here, things look like it's not moving at all. When you look down here, it looks like everything's moving high speed. What you're really doing is looking at yourself from different points of view, different perspectives, but they're all one, there's no disconnection. So all the major religions in the world, they like to say everything's all one, right? So this is an example of how it's all one and all connected. And all you're really doing is seeing yourself, because yourself is all there is. Now, this is the universe's, the view of the universe as a human being, though. There's much more to the universe. It's beyond the scope of this YouTube video. But as a human being, this is what we see. I know it looks sort of like a prison, like there's no way out, like a centripetal machine of some sort. But there is a way out, because you are this machine. You are this universe. But as a human being, which is manifested within this universe, this is how it's going to appear to be. Much like a video game character, if they were to try to see the world outside the video game, they couldn't, because they can only exist and manifest from within the game. If they left the game, then they would no longer exist anymore. So, as a human being, this is how we see things because this is how human beings see things. However, consciously, we can be aware of far more than what we see with our eyes because we are the consciousness within all this. So I don't mean to blow anybody's mind or confuse you or to leave you in the dark or create any more questions for this answer. But this is simply how it is. It's just one giant centrifugal machine, and there is a way out of it. There's a way through it, and it's simple to understand. It's simply a place that your mind is seeing, and it's how your mind perceives it, because your mind is a manifestation of the very thing that it's looking at. Alright, well, that concludes this video, and depending on what kind of emails, what kind of responses I get, will determine what common questions I get and what the next video might be. If you need this more clear, well, I don't really care. I don't really think people are ready for this knowledge, but I thought I'd put it out there anyway because, you know, you have people like Deepak and Michio and Eckhart Tolle. People seem to be ready for them, so I thought maybe some people out there might be ready for the truth. All right, good luck, and maybe talk to you later. Bye.